So today I'll be doing the whole array section in this video so that it's like a array marathon, uh, and who's on the same journey can uh, view this video in the form of support while they're doing it, so that I discuss briefly into how to solve the problem and I code it so that it's like a companion video for you. Okay, now let's get started. Now let's see the two-sum problem. We are given an array and a target value, so we need to return indexes of the numbers whose values add up to the target. Okay, and we cannot use the element at the same index twice. So it's 6. I cannot use 3 twice. Uh, okay, that's one part of it. So now, how do we solve it? So, like the approach that I've thought of is that I iterate over the array, and if let's say I start with 2. Okay, now as I found 2, I need to find the remaining value, which is 7. As I've iterated only till 2, I have not found 7, so I move forward. Now I came to index 7. Okay, here I need to finish the target, and if I see in hash map that we'll be using to store these values, I can see that like 2 was found in index 0. Okay, so now I use that and return the value. Okay, that's the approach. If map contains the key domain, then what we can do is we can return current index and index of the remaining value. Okay, if not, what we do, we just add this value, saying this is its value and this is its index, so that numbers we see in the future can make use of this. And if we haven't found anything, then we return an empty one. So, okay, now let's try some edge cases. So okay, minimum length is 2. Okay, it's been covered, and saying valid answer exists. I think they've covered the edge case. Yeah, let's try submitting. Okay, this works. Now let's see the second problem. This is the best time to buy and sell stock. Okay, so okay, you buy a stock on a day and you sell a stock in the future. So if you buy it for low price and sell it for high price, you make a profit. And we want to find the maximum profit that we can make. Okay, so this was my approach. Again, this could be solved in multiple ways, but the approach that I've used is, so I see what's the value at day 1. Okay, so it's 7. So now I go forward. I mean, uh, I want to find the minimum day to buy it, like a day with minimum price to buy it, and a future day with highest price to sell it. Okay, so I keep on tracking the minimum value that I can see till now, that I found till now, and try to sell it on a day and see what the profit is. And as I keep on iterating, like I'll try to choose the maximum profit every time. So 7, uh, 1 minus 7 is minus 6. I mean, it's not reasonable or logical to say. Then uh, what I next I go to 5. Before going to 5, what I do is like it what is the minimum price to buy? Like, yeah, I keep checking that. So 1 would be the minimum price to buy that I've seen till now. Next, so 5, I try to sell it. 5 and minimum price I've seen till date is 1. 5 minus 4 is 1. Actually, 5 minus 1 is 4, and 4 is the maximum profit that I've seen. And next, 3 minus 1 is 2. Still 4 is still the maximum profit. 6 minus 1 is 5, and 5 is the maximum profit that I've seen till date. 4. So that's the approach that I'll be taking. Okay. Okay. Um, minimum price to buy is let's jump the value. Okay. And yeah, price always still. Okay, let's initialize this be 0 in case there's no profit. Okay, now I check. So I'm taking the max before the maximum I've seen till now and selling on today's. Okay. Um, it's like what would happen if I sell today? So let's make a small adjustment, shall we? So as I have to buy it on the first day, I'll take the first day price, and as I can only sell from the second day, I'll do so minimum price that I've bought till now, and that will be my maximum profit. And as I'm looking into future days, I'll consider this day as all the days for buying if in case it has lower price than the minimum buy price. Okay. Think let's see if I have missed anything. Okay, that's good. Uh, let's test the corner cases. So for the RF size one, the price is 0. Let's see. Yeah, price can be 0. What if price is 0 continuously? Yeah. Now let's see if it works for these cases. Yeah. I've tested the cases. I think should be good. Let's hope there aren't any cases. Yeah. Thank. Okay. Cool. Okay. So we're given array of numbers and we need to return true if a value appears at least twice. And we need to return false if every element is distinct. Okay. There are multiple ways to solve this. I mean, we can keep on adding elements into a hash set, and before adding, what we can do is like we can check if the number I'm about to add is already present in the hash set. And if the number is already present, then it's a duplicate and we return true, saying that there's a duplicate. If not, if you're able to add all the elements into the hash set, then that means there are no duplicates. That's one way to go about it. Okay. Okay. Let's try. that contains number before then if not, and if I'm able to come out of the loop before the return, that means there are no duplicates. Okay. Let's see if there are any edge cases that are testing. An array of length one. Let's see. And that shouldn't, if it was zero, then it should have been array. Or I don't think that's pretty much of an issue. Okay, let's try submitting it. Okay. Now product of the array except itself. So okay. So let's first see the problem. I mean, if you're at index 0, and we need to return the product of all the elements except this element. So 2 into 3 into 4, it's 24. And if you're at index 1, so if we are here, we need to return the product of all the elements excluding this. So 1 into 3 into 4, it's 12. Similarly, if we are at 3, we just exclude 3 from the product of the array. So again, luckily, these guys have shown the some of the cases that we need to think more about. So if it's 0, okay, so for all the elements, it will be 0. And for 0, it will be product of all other elements. So previously, after seeing that, I thought, okay, I would take the product of all the numbers and divide it by the number uh, at that index, and I could get the value. But with 0, that will cause an issue. And again, if there are 2 zeros, then there'll be 0 for all the indexes. So if there is 1 0, it will be like it's fine. So it's product of all the elements except this. If it is 2 zeros, then it will be 0 everywhere, because when we come at this 0, the product will still be 0 because there was a 0 somewhere in the array. Okay. I mean, if it's 2 or more zeros. If there is a single 0, yeah, it's fine. So what I'll do is, like, I'll take product of the array excluding zeros, and I'll keep a count of the zeros. If it's a single 0, what I do is, like, when I encounter a 0, if it's single 0, then I'll return the product. But when I encounter a 0, and if there are two, if I find out that, like, there are a total of 2 zeros, that means the product will be 0 because there was a 0 at some other place, right? So that was the logic. Then it's not as clean as I thought it would be, but yeah, that was the logic I came up with. So I'm using so product. Now if I'm in popular excluding zeros, so if number is equals to 0, I'll just increment the 0 count or multiply. Okay, so fine. So product of array. Okay. Now I need to return the result. So to return the result, then I thought, instead of creating an array, I could use the same array. I mean, it doesn't make any difference. Okay, so first, if number is equals to 0 and 0 count is greater than or equal to 2, then even here the product will be 0, because here we have 0 in the current position which we are looking at, we have 0, and there's a 0 at some other position other than this, so which makes the product 0. Okay, if not, if there was only a single 0, then that will be equal to product. And if it's not equal to 0, and if there is at least 1 0, if there is at least 1 0, then the product will be 0. If not, equal to wait, sorry, okay. Um, let's test the case. There are multiple zeros. Two, and put the minimum zero there. It's two. Okay, that should matter. So, well, should matter too. Okay, I think we are good to go. Yeah. Hello. 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 Okay, now let's see the maximum subarray problem. Okay, so here we are given an array and we need to return the subarray which has the largest sum. So think as we are saying it's a subarray, I think it needs to be contiguous. Okay, so this is a example of a sliding window problem, which that I've done is straightforward. It's similar to sliding window problem. What I do is like start from an index and I keep on adding all the elements until the current sum is positive. If at a time the current sum is zero or negative, what I do is like I discard the window and start the window freshly again. Okay, so if okay, see, I started with -2, and okay, the windows my current window is negative. I discard it. I'll start again 1. Okay, my current window sum is 1, and when I go to -3 again, the sum is -2. So discard the window, start again 4. Okay, my window sum is 4. 4 minus 1 is 3. Okay, still positive. 3 plus 2 is 5. Still positive. 5 plus 1 6. Still positive. I still keep the window 6. And if you can see 6 was the maximum sum that we've seen up until now, and I've add -5 to the window. 6 minus 5 is 1. The window is still positive, so I keep on continuing with the window. 1 plus 4 is 5. So this was the window starting from 4. Okay, and that's the maximum sum. So we need to return the maximum sum, and we keep track of the current sum. That's pretty much it. If the sum equals to 0, reset it. And I think we full return step. We need to see if the current sum is maximum. Sum current sum, right? And then we return the maximum sum. Okay, I think it's typo. MTE. Yeah, let's run it. Yeah. Okay. Uh, maximum product. So okay, let's see this problem. We're given an integer array and it finds Subarray as the longest product, and we need to return the product. Okay. So okay, I've tried different approaches for this problem, but I couldn't come up with an optimal solution. So I've looked at the solutions and understood what they're trying to do and how they're solving it. And this, it was as follows. So uh, we keep what do you say? Yeah. Okay. So the approach was like we have a concept called prefix sum. So we keep on adding values into the so like so prefix sum it goes something like this. So at a current index, we have the sum of all the values from the previous index, including the current index. So if you see this, it will be 2 here, it will be 2 plus 3, here it will be 2 plus 3 plus minus 2. So similarly here we're following a prefix product kind of approach, and we'll be having two prefix products, one from the left and one from the right. Okay, and every time um, we take the maximum of those. Okay, so one product prefix will be starting from over here. So it'll be like 2, 3, minus 2, and another will be starting from the 4, minus 2, 3. So the reason is that uh, because we have negative values, uh, so if it's minus 2, uh, again, if just this number was negative and all of these were positive, and like, all of these were positive, the highest value will be found by this right prefix, like that's coming from the right, 4, minus 2, I mean 4, 2, 3. Okay, because as this is negative with the left prefix, all the numbers will be negative and we will never find the largest product. Yeah, that's one thing. And one more thing, what we do is like during this prefix, if we find a 0, we discard it and we reset the product value to be 1, because uh, it's like this. So if there's a 0 at the start and at the end, so what it is like, we don't want 0 in our product because it makes it 0 and we can never find the maximum value. So we just ignore 0 and take the other values. Okay, yeah, think that's pretty much. Let's start. The right prefix product. So as we are coming from the right side, it will be like, okay, now I'll take the maximum. And these. If left prefix product as from 0, experience less to 1, or experience 0, and to 1. And I've got the right logic. Let's try. Okay, let's try some test cases. This is one value, 0, and we yeah, think let's try with these test cases. Okay, yep, I think that's pretty much it. Now the left prefix, now the right prefix, we keep on taking the maximum. If at a time they become 0, we reinitialize them. Yeah, that's pretty much it. Okay, so problem is finding a binomial rotated sorted array. So again, here we follow the binary search approach. What you're searching for is this element. Okay, how do we know that we found this element? So if we found this element, the previous and the next will be both greater than this element. So if you can see, for all the elements, the next will be higher and the previous will be lower, except for this element. Okay, so for this, the previous and next will both be high, greater than it. So that's how we know we found it. And then the next thing that we do, uh, okay, how do we know whether to change the left bound or right bound? I mean low boundary or high boundary. So if let's assume mid is over here. I mean this portion. I mean before the minimum. So if it is over here, what we want is like we want to push the left boundary to mid, so that we are closer to this element, closer to this this element. If we are at a position, we are here in the right boundary, then we'll push high to mid. So how do we know like whether we are on the left side of the zeroth element or right side of the zeroth element? So what we can do is like we can see the first element. So if you see the first element, and if mid is greater than the first element, then we know that we are on the left side of the left side of the min. If the mid is less than the first element, then we know we are right side of the min. Okay. So in case if it was rotated sometimes or like rotated uh, equals to rotations equal to length, then what happens is like we with the logic that I said now, it will not find it. Then we just return the first element, which means it was first element all along. I mean, it was without any rotations. The logic that I suggested only finds the value if there were any rotations. Okay, so let's put 0 is -1 in standard binary search logic, and we'll use previous, next, and mid. Okay, so I already made that mid to. Okay, now what's previous? Okay, sorry, nums is less than nums of previous, and nums of mid is less than nums of next. Then we find the minimum element zero time. Sorry, is greater than, then you're the left of the lowest element, then we push the boundary. The left boundary goes right, but not boundaries. Then it's a zero question. Okay. Okay. Okay, let's try some tests. Okay. uh, yeah, yeah. So yeah, if it is at the last, I should consider the rotation. Yeah, that's what I was thinking. So use to take care of the rotation. Yeah. Okay. Got it. Okay. So the search is just an extension of this. So what we can do is we first find where the pivot is. I mean the position of mid, and once we got that, it's we can solve the problem using binary search. If you find the mid, we know from here till the end would be one, what we call, one array in ascending order. If not, it's another array in ascending order. We check the boundaries. If the target is between 0 and 2, then I do a binary search within this subarray. If it's not, then I do a binary search between 4 and 7. So that's basically the binary search logic. So what it is, like, we use the search and rotated sorted array to find the pivot and check if it's between this subarray or this subarray, and based on that we'll do the binary search. Okay, so it's the threesome problem. We need to return list of all possible uh, value sums whose sum is equals to 0. So like list of all possible, and we do not want any duplicates. So if there were like I mean 4 minus ones, then what, we only need 2 of them, so it will be like 4C2, and if we add a 2 to it, there'll be all those possible combinations will be 0, but we do not want, we just want a unique combination, just a unique combination. Um, if we have taken minus 1, 2 once, we do not want minus 1, 2, even if those minus ones are at altogether different locations. So the approach is, what we do is, like, first we sort them. Okay, sort terms. Okay, now target, that will be right. Now let's find the targets. Okay, so what is, like, left is y plus 1, right is n minus 1. uh, whatever. So we have the sum, and if the sum is 0, yeah, I think we found a combination, right? So if the sum is 0, then I already do the result. Okay, I'll initialize the element. Okay, So this is the possibility we will be of that. So nums of I, well, this nums of L, and this is nums of L and R. And as we do not want any duplicates, what we do is like plus 1. We keep on moving forward. We keep on moving forward. Yeah, that's right. And as is the case when sum is equals to 0. So yeah, let's just probably run this. If sum is greater than 0. If it is greater than 0, then we need to reduce the value as the array is sorted. If we move the right pointer towards the left, that should do the trick. Not sum would be less than 0, then we need to increment it. Yeah. And again, as I do not want duplicates, so I is equal to I plus 1 and I less than stop length. I think that's pretty much it. Okay. Well, then, should I stop? Okay. That line 27. Sure. Let's start. Similarly, y plus 1 is less than n. We're gonna lose. Uh, okay. So we should have found this, but it hasn't. So let me add some log. So here, um, maybe That was the issue. So because here there's I plus plus, so I need not skip it. It'll be skipped by the for loop. Okay. Yeah. And so yeah, so they're given these boundaries with some lens, and it's filled with liquid. And once we stop filling it with liquid, like, only the water will stop between the boundaries, and we need to find the maximum uh, amount of water. We can do that by finding its maximum area. Okay, so if you can see, we start with left and right boundary. So the difference, yeah, so to find the area, it's like because we take the minimum height, because if we take the maximum, the water will not stop over here. So water will stop below to only this level. So we take the minimum of the heights and the difference between them, between these indexes. So using that, we find the area. And once we find that, what we do is like we, as this is smaller, and no matter how big the container is, like uh, this is the level this smaller container can hold. So it doesn't make sense if we stay the smaller container. So like we we leave the smaller container and move towards right. Okay, we find another bigger container. And now we take the area, these two. And as this container is even bigger, we'll try to see if there is a container that's bigger than this. So we skip from here, we start moving towards the left. Okay, so this could be one of the containers. So basically that's the logic. I mean, I went in the most detailed explanation, but uh, that's how it goes. Area, let's see. Okay, okay. Control symbol, control symbol. Okay, and right, because I declared it wrong. Index 9 found. Okay. Oh, should move towards the left. Okay. Okay. Well, yeah, I think I'll leave it done with the other section of the blind stand 5 LeetCode questions.